All right, you guys can see me and you can also see the paper, right?
Yes, sir.
Okay, good. I'm gonna go ahead and cover a little bit of the work that I did so you guys can follow along. So basically, we said that we're starting with 760 kilograms of iron, and we want to know how many kilograms of iron. So basically, we're trying to figure out how many moles of Fe2O3 are needed to produce 760 kilograms of iron, right? Because that's the way the reaction runs. But since we're trying to solve using stoichiometry, we set up start and finish based off of the problem, based off of the bridge that we're forming, okay? So if you set up your bridge notation, you will know that you're going from grams, so from mass, to moles of a different molecule, okay? So if you look up here, then you're starting with grams of molecule 1. You need to convert to moles of molecule 1, then make the jump to moles of molecule 2, because moles of molecule 2 is what you want to finish with, okay? So we're going to have to make a bridge with two columns, right? We have one column here and we have another column here, and that's exactly what we did, okay? So I went ahead and I made the bridge. I wrote it out, okay? First thing we do is that we write 760,000 grams of iron, right? We write that there and we put it over 1 because that's what we're starting with, okay? Then we have to convert into moles of iron. So to convert into moles of iron, we need to see how many moles of iron, how many grams of iron there are in 1 mole of iron. How do we figure that out? Brian, what do we use to figure out how many grams of iron there are in 1 mole of iron? What can we use to find that out? It's a pretty straightforward thing that we've been doing.
Periodic table.
Periodic table, exactly, right? So you go right here to your periodic table and you find iron. Iron's right here. Now iron, it's probably a little blurry for you, but it says 55.845 grams of 1 mole. So 1 mole of iron, right, is going to have 55.845 grams per mole. It's okay if your periodic table says 55.85. Most periodic tables round to 4 significant digits, so that's okay. All right. So I went ahead and I just wrote that out here. So we have the grams of iron, and then we have 1 mole of iron over the mass of 1 mole of iron. Okay, so now we can already start seeing that we can start canceling things out, right? We know we want to go to moles next, moles of the first one. So grams of iron is going to cancel out with grams of iron. Now we have moles of iron, but now we need to make that jump from moles of iron into moles of Fe2O3. What do we use to make that jump? We have to use the mole to mole ratio. Okay, so we use the mole to mole ratio, right? There is 1 mole of Fe2O3 per 2 moles of iron, right? We only use the coefficients to figure that out. So we write 1 mole of Fe2O3, we write it on the top because that's what we want to get to. And we write moles of iron on the bottom, 2 moles of iron on the bottom, because the moles of iron need to cancel out, okay? This is where we make that jump, that transition into a different element or a different molecule, okay? Now, all we need to do is just write that out on our calculator, okay? So basically, we have 760,000 grams, right? Because we converted 760 kilograms into 760,000 grams. Okay, you guys need to be able to know how to do that. So 760,000 grams divided by, right? Because we're the little person walking on the bridge. Okay, the next thing we see is that on the underside of the bridge, which means division by 55.845, right? And then we multiply by 1, but we don't really need to multiply by 1. The only non-1 integer that we have here is 2, so we're just going to divide by 2, and then we're going to get our answer, which is 6804.5, and then I just went up to the 4th decimal there, okay? Now, are we done? Can we say that this is our final answer?
No.
No, we cannot, okay?
You have to round to 3 significant digits.
Okay, so we would think we would round to 3 significant digits, right? Because everything that we've been doing has 3 significant digits. But let me ask you guys, How many significant digits did we start with? Look at the starting number. How many significant digits?
Two.
Just 2, right? Why? Because trailing zeros are not significant unless what?
Unless there's a decimal.
Unless there's a decimal. Exactly.
Sure.
So here we only have 2 significant digits, right? But here I have 5 significant digits. Does it matter?
No, because it's
No.
what you start with.
Exactly. It's what you start with. You don't think about conversion factors, right? All of these are conversion factors. We don't count those in significant digits. So that means I can only have these 2 significant digits. So what's my final answer going to be? 4 or less, I'm going to let it rest, right? Which means that my final answer is going to be 6800 moles of Fe2O3. And that's my final answer, okay? Do I have 2 significant digits in this answer?
Yes, sir.
Yes, you do. Good. All right. And we went to moles. That's what we wanted at the end. We finished in moles. We're done. Okay. Got it? Good. Give me a little thumbs up on the thing if you got it.
Thumbs up, sir.
I'll leave this up one more second so you guys can see. 5, 4. Let me take this out of the way. 5, 4, 3, 2, and 1. And we're going to move on now to another problem. And we're going to move on to problem number 22, okay? Sorry, number 23. All right, so first thing you want to do, and I wish I would have prepared this beforehand, but this is still chapter 9 review, okay? And we are working on page 250. And what number are we doing? We're doing 23A. Okay, we're starting with 23A. Okay, we're only going to go 15 more minutes, just so you guys know. We're going to do as much as we can. The last thing, I do need to get to G and H. So we're going to do A, then we're going to do G and H, okay? So how many moles of NaO? You know what? Let's skip that. Let's skip A, and let's go ahead and do F, G, and H, okay? So not A, let's do F. 23F, okay? 23F is a little bit more difficult. Let's go ahead and let's write out the chemical equation. Can someone read it to me so it's faster? 2NaOH plus, no one's gonna read it to me? Fine, I'll read it. NaOH plus Cl2. Can you guys hear me? Can everyone hear me? Yes, no, yes.
Yes, sir. Now we hear you.
Okay,
Yes.
okay, good. So NaCl plus NaOCl plus H2O. Now remember, just to save space, we're not writing out the what's it called? The states, okay? All right, so we have this here. That's our equation. What's our question? How many grams of NaOH will react with 37.5 grams of Cl2? So we're starting with what and we're finishing with what? Emma, what are we starting with? What is the value that they give us to start with? In 23F. Basically, the only numerical value that you see there.
2.
In 23F. So it says how many grams of NaOH will react with 37.5 grams of Cl2. So basically, whenever you get like a number, the number that you get, right, that they give you, that's kind of almost always what you're going to start with, okay? You have to dissect it sometimes because they may give you multiple numbers, okay? Just know what you're starting with. In this case, it's going to be 37.5 grams of Cl2, okay? So basically, if you start with 37.5 grams of CO2, how many grams of, what is this? NaOH are you going to produce? Okay. So we're starting with grams, we're finishing with grams. Now that means that if we go on our bridge and if we're starting with grams of 1 and we want to finish with grams of 2, right, we're going to have to go through these two things, and we're going to have to go to moles of 1 and then go to moles of 2 before we can go to grams of 2. Okay? Are you guys following along? Is anyone lost? You have a question before we continue?
No, sir.
No? Okay, so let's go ahead and do it. I think someone went ahead and wrote or like drew on the screen like a little blue line. See if you guys can erase that just so it doesn't mess up the video there. It's okay if you did. I'm sure it was a mistake. Okay.
Yeah, that was me, sir.
Okay, no problem, no problem. So we have, in this case, we know we're going from grams of 1 to grams of 2. So we know we're going to have 3 columns, okay? And that'll just become more evident the more that you work through these problems, okay? All right. So what are we starting with? We're starting with 37.5 grams of CO2. And this one's nice because we're actually starting with a reactant, okay? And we want to finish with the grams of a product, okay? Or actually, okay, so we're actually finishing with grams of a reactant as well. But that's totally fine because we're still going to use the same exact process. It doesn't matter if we're jumping from a reactant to a product or not, okay? The important thing is that we're jumping from one molecule to another, okay? So we still have to use the mole-to-mole ratio, all right? So we're in 23F, right? Okay, so we start with this. Now, we need to go from grams to be able to make that jump. What do we need to convert to? What do we need to convert to make that jump? We can only jump
Moles.
with moles, exactly, okay? So we know we want to go from grams of CO2 to moles of CO2, right? And how do we go from grams to moles of CO2?
Check the periodic
ratio.
table.
Not mole-to-mole ratio, we have to use the
Periodic table.
Exactly, right? Now, very important, guys, because it's so easy to make this mistake. You are finding moles of Cl2, not just moles of Cl, okay? So your grams have to reflect grams of Cl2, okay? So the best thing you can do is just write that out. Cl2 is going to have how many grams? If you look at Cl, here, we're going to have 35.45, okay? And we're going to write that out. That's for 1, okay? 35.45, but that's going to be times 2. So what is 35.45 times 2? Can someone do that really fast? It's going to be like 70, 90 or something. No one going to do it?
70.9.
70.9, I think.
Okay, perfect. So 70.9 grams. That means that that 1 mole of CO2 is going to be 70.9 grams of CO2. Okay, so we've done this part so far. Good. Next step. What's the next step? We went from grams of CO2 to moles of CO2. Now we want to make that jump into moles of NaOH, right? Remember, before we can go from grams to grams, we need to go from grams to mole to grams, okay? So mole of 2, which is the next one right here. We want to go to moles of NaOH. And what are we going to use here now?
Now the mole-to-mole ratio.
Now we use the mole-to-mole ratio. So how many moles of NaOH are there for how many moles of CO2? How many moles of NaOH?
2.
2 for every 1 mole of CO2, right?
1 mole.
1 mole, right? Whenever there's nothing, that just means
Yo, I
1.
hear him so glitchy.
Okay? It's glitching for you? If it's glitching, then just like try your best to follow along. I think the video will still be okay, so you can just rewatch it, okay? Now we went to moles of NaOH. Now we want to go to grams. Okay, now we want to go to grams of NaOH, which is the last step, grams of NaOH for 1 mole of NaOH. And now what do we need to do here? How do we figure out the amount of grams of NaOH for 1 mole of NaOH? We need to use the periodic table again, okay? And we're going to break this up, right? We're going to find out how much there is in Na, how much there is in O, and how much there is in H. We're going to add all of that up, and then we're going to get the atomic mass, right? Sorry, the molar mass, okay? So we start with Na. Na is sodium, which is 22.99. So we have 22.99. Then we go to oxygen, which is up here, which is just going to be 16.00. And then we have hydrogen, which is up here, which is 1.008. Okay, so we're going to go ahead and just do that. You can add it up using just like regular arithmetic, right? Elementary school adding, or you could just use your calculator, and that's a lot faster. Okay, and then you have 39.998 at the end. Okay, and that is the molar mass of NaOH. A lot of times what you can do, guys, and this is like me telling you how to do this a lot faster, aka cheat, is just Google what is the molar mass of NaOH, and then you don't need to work this out. You have Google at your disposal. Just go ahead and Google the molar masses. There's no point in going through the periodic table or writing everything down if you can just find the molar mass. If you know what you need to do, then it's totally fine with me if you use your resources to do it even faster, okay? So go ahead and write 39.998 grams of NaOH, all right? And let's go ahead and let's solve. So now we just use the little guy walking across. We have a little guy walking across. We're going to cancel out all of the
grams.
Yeah, we're going to cancel out here grams with grams of that. Moles of CO2 with moles of CO2. Moles of NaOH with moles of NaOH. If you can't cancel everything out except the last one, then that means that you set it up incorrectly. Okay, so important that you cancel everything out before you start doing all of the operations. Okay, make sure everything gets canceled out so you finish with what you want. All right, so let's go ahead and let's just walk across the bridge. We start with 37.5 divided by 70.9 times 2 times 39.998. Now, some of you guys may have gotten 40 for this, and that's okay. It's basically the same thing, okay? You add that together, and this is what I get. I get 42.3110. Okay, and let's see if this makes sense. Basically, what you're saying is that for 37.5 grams of CO2, you're going to need 42.3110 grams of NaOH. Okay,
Isn't it 5 significant digits?
How many significant digits should we have? That's the next step here. So what do we start with, Brian?
42.
What was our
311?
start? Our start. The very first thing we started with.
Oh, 37.5.
37.5, right?
Oh, so there's only 3.
Only 3, exactly. Only 3 significant digits, right? We don't count this. We don't count this. We don't count this. Okay, because those are all conversion factors. That means we can only keep these 3, right? So what's exact? That's our final answer right there. Okay, 42.3 grams of NaOH. Final answer. Okay, got it? Thumbs up if you got it.
Got it.
Got it. Yes. Good. All right. Perfect. Let's go ahead and let's. How much time do we have left? Oh, we have 1 minute left. Okay. This is what I'm gonna do. You guys are free to go if you want. I'm gonna go ahead and work out letter G. so you guys can see, because letter G has one more very important part to it, which is the percent yield that you do need to know. Okay, I'm gonna work it out. You guys can go if you want. Before you leave though, let me make sure that all the participants are here. Brian, Camille, David, Ethan. Okay, so Abby took off. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, good. So you guys are good. If you want to stay, that's fine. I'm gonna keep recording though, so that we can knock out this last problem, because we still have more than 10 minutes left in this call. All right. Okay, so you could just leave if you want to. That's fine. I'm gonna keep working over here, and I'm gonna keep explaining like if you guys are still here. Okay. All right. So we're gonna go ahead and we're gonna finish. We're gonna do letter G now. So we're gonna do 23G. Okay. Now we're gonna use the same chemical equation. Okay, so I have the same exact chemical equation up there for us to see, for us to use. Okay, but now we're going to try to figure out what this 23G asks of us. And 23.
You want me to read it to you, sir?
Yeah, please go ahead and read it to me.
Okay, it says, what is the theoretical yield of NaCl in grams?
Mm-hmm.
In this reaction, if 100 grams of NaOH react.
Okay, perfect. All right, so big words there. Theoretical yield. Theoretical yield. Do not get scared by this word. All this means is how much you should get. That's it. Okay? According to the equation, how much you should get. Basically, everything we've been doing so far. That's nothing has changed. Okay, we're still doing start to finish, right? Because before we said in the previous problem, right? Right here, if I have 37.5 grams of chlorine, I should have 42.3 grams of NaOH. Okay, so why make a term like theoretical yield? Basically, this equation is our template, right? This is what should happen, right? But that doesn't always happen, because like we know, we're humans and we make mistakes in the lab a lot of times, okay? So theoretical yield is basically what you should get according to the reaction, right? And there's another thing called the actual yield, which is what you do get if you conduct the experiment, okay? That's all that means, okay? Super, super simple. Theoretical yield is what we've been doing, okay? What you should get according to the reaction, according to the paper, like problem, okay? Actual yield is if you're going into the lab, let's say you spill your beaker, or you start squirting each other with the little squirt bottles, right? And some of the water gets into your beaker when you're doing the experiment or something like that. It messes up the experiment in some way. Then you get the actual yield. And there's always other reactions happening in the reaction that you're conducting. There's always like side reactions happening at the same time. So your actual yield will almost never, ever, ever be your actual theoretical yield, okay? Which then takes us to the next question, which is question H. Basically, when you find out your percent yield, which is how close you got to the theoretical yield. Super easy concept. Nothing has changed, except at the end, we're just going to compare our actual yield with our theoretical yield, okay? We have 10 minutes left in this call. I'm going to try to race through this. Okay, so G. What is a theoretical yield? Basically, what do you get in grams of NaCl in this reaction, the same reaction that we've been doing, if 100 grams, so you have 100 grams of NaOH react. So if you have 100 grams of NaOH, basically how many grams of NaCl should you get? This is exactly what we've been doing. Okay, so let's go ahead and let's do it. All right, let's form our bridge. First of all, we know we are going from grams to grams, which means we're going to have 3 columns because we need to do the conversion between both the moles, okay? So if we start with 100 grams of NaOH over 1, and I'm going to go through this, but you guys can pause the video when you look at it on YouTube. We have 100 grams of NaOH, right? And we want to now go to moles of NaOH. How many grams of NaOH are there per mole of NaOH? We did that in the previous problem right here, right? We got 39.998. So always keep your work because it could help you. What was it again? 39.998. Let's just say 40.00 grams of NaOH per 1 mole of NaOH. Now we make the jump. Now we go from moles of NaOH to moles of NaCl because that's what we want, right? Moles of NaCl.
Yeah.
Exactly. Okay, and what do we use to make this jump?
Mole to mole ratio.
Mole to mole ratio. Exactly. Okay, and what is the mole to mole ratio? Moles of NaCl is going to be 1 mole of NaCl for 2 moles of NaOH. Good. Now, next step, we want to go from moles of 2 to grams of 2. So to be able to do that, now we're going to grams of NaCl over 1 mole of NaCl. And now we need to use the periodic table for that, right? Okay, so you can use the periodic table or you could just ask Siri. Siri, hey Siri, what is the atomic mass of sodium chloride?
The answer I found is 57.96 atomic mass units.
Okay, 57.96. Let's hope that she's correct. Sodium chloride, NaCl, right? Yes. Okay, someone check that for me while I finish working out this problem. Make sure that I got that right. Or that Siri got it right. Okay, so here you have 57.96 grams of NaCl over 1 mole of NaCl. Let's make sure that everything cancels out. We have grams of NaOH, grams of NaOH, moles of NaOH, moles of NaOH, moles of NaCl, moles of NaCl. Okay? Now, and in fact, Siri got that a little bit wrong. We're going to go ahead and tweak this because the book says, oh wait, this is G, right? The book says this is not that. Let's make this 58.44. Okay, so one of you guys, please go ahead and try to solve this. Find the molar mass of NaCl. You just add sodium and add chlorine together and tell me what it is, if it's 58.44 or not. Okay, next step, what I want to do is I want to just walk across this bridge. Okay, let's walk across the bridge. We're going to walk across the bridge. To do that, we're going to get our calculator. 100 grams divided by 40 divided by 2 times 58.44. We're going to get this answer here, which is 116,116,880 grams of NaCl. All right, so that's what we get there. Yes, tell me.
Isn't it that you divide all of the bottom ones on the bridge? You divide the bottom ones?
You divide the bottom ones. Did I not? I didn't, right? I multiplied, and that's
No.
why I got the wrong answer. Good job. Thank you.
Yeah.
Yes, exactly. I multiplied by accident. So 100 divided by 40. Thank you. Divided by 2 times 58.44. And that gives me the right answer because this answer was completely whack. That's a lot of kilograms for a small reaction, right? So we have 73.05 grams of NaCl. Okay. Now, since we have that, what's the next step? To find out what? Significant figures, exactly. Okay. How many significant figures did we start with? One significant digit. Okay. Since we started with one significant digit, we can only use this one. 4 or more. 4 or less, let it rest. What's my final answer?
70.
0. So 70, sorry, I messed that up. 70 grams of NaCl. okay? Because I can only go to 7, 4 or less, let it rest.
Oh
70
yeah.
grams. Here I have one significant digit, right? In this final answer, I have one significant digit, so that's okay. 70 grams of NaCl, okay? That's how you do this problem, right? Theoretical yield just means how much do you get, okay? Now let's look at the next problem, which is letter H. That tells us if instead of getting this, let's say instead of getting this, you did the experiment and you got 68.45 grams, right? Let's say that Matthew and Pineda were using the squirt bottles and some of the BI water got into their beakers, so they messed up their experiment a little bit, very little, right? It's still very close. Let's say that you got this in your, when you did the experiment, this is your actual yield, okay? This here is your theoretical yield, okay? So all you have to do, super easy equation, okay? We're gonna go ahead and do it, and it is ready. This is the equation for percent yield. Is gonna be actual over theoretical times 100%. So that's all we have to do. We're gonna go ahead and do that in our calculators. I'm gonna write it out. To find out the percent yield, we're gonna get the actual that we got. Let's say that we did the experiment, and instead of getting 70 grams of NaCl, which is what we think we should get, we're gonna get 68.45 grams of NaCl. Let me just double check this. Okay. Over the theoretical, which is 70 grams, over 70 grams of NaCl times 100%. If we work that out on our calculator, we're going to get 68.45 divided by 70 times 100%. And this is what we get. We get 97.785%, right? But remember, percent, we only want to go, in this case, so your book says that you just round up to one significant digit, right? When we're dealing with percentages though, we could go ahead and just figure out that this here is one significant digit. So our final answer would be 100%. So basically you still got 100% yield. But when I give you a problem of percent yield, I will tell you what to round to. For the most part, it'll be to the nearest 100th percent, okay? So two ways to do this. If I don't tell you what to round to, then you follow the significant digits, right? This is the first significant digit here, one significant digit, which means that you're just gonna round to 100%, okay? And if not, then I will tell you where to round to.